everyone. I'm Kristen. This is Rufus. Hi. You say hi, buddy? And let's see, Rufus is a parrot, and I'm a grad student at Michigan State, and I am just about finishing up there with my PhD, and I study black holes, which are pretty cool. And hey, Rufus, can you say hi? Rufus has lots of opinions. Let's see. So I study black holes. I do observations of black holes. Hey, buddy. And one of the things that's cool about them, so we can't actually see black holes, right? But we can look at how they interact with other matter around them. And so that's what I do. So stars we can look at because they give off light, like the sun we can look at. But when you can't reflect light or give off light, then we can't actually look at you. But one of the cool things about black holes is they're so massive as they interact with everything else around them. And there's a couple ways they interact with things around them. Hey, buddy. And one of the ways they interact with things around them is through gravity. So gravity is like what is binding us to the Earth right now because the Earth is more massive than us and it's pulling us down. But gravity is also what's making the Earth rotate around the sun as well. Yeah. And so black holes are so massive that if things get too close, they can get sucked up by the black hole, right? And if they get too close, then the black hole will actually grab them like that and not let them go. But if they stay far enough away, then they'll orbit the black hole as well. And one of the things that we can do with the orbits is we can study the orbits of things. And so how we found out about the black hole at the center of our own galaxy was we looked at a bunch of stars that were orbiting what looked like nothing. So we were able to trace out the patterns in the motion of the stars that were orbiting seemingly nothing for about 20 years. Do that for long enough, you can figure out what's the mass of the object that's driving this motion. And so that's how we learned about the black hole at the center of our own galaxy. But that's not what I do. So I look at black holes that interact with stars in another way. So the second way that black holes can interact with things is via a process called accretion. And what happens is that you have a black hole with another star that's orbiting it closely. And they're, going around and hanging out together and orbiting each other. You're pretty messy, buddy. And what happens is the black hole starts to steal material from the star. So stars are just like these big balls of hot gas, and the black hole can just steal hot gas. And when it's doing that, so the star is rotating, and rotational motion is always conserved no matter what. So this is kind of the classic example of this is when you have an ice skater doing the twirl. And so when they go into the twirl, they can pull their legs in close and move faster or move the rotation out and spin it slower. Hi, buddy. So what happens is that the gas that the black hole steals actually winds up spinning around closely around the black hole, and it creates a kind of a disk. And that disk gives off light and energy that we study. Hi. And so that's what I look at, is black holes that steal matter from other things. But even though black holes steal matter in some way. Do you want to go back to your perch, buddy? You done? No? You just want to yell? So even though they are stealing material, there's kind of this expected limit. So there's this kind of rule of thumb. All right. No. So this person named Arthur Eddington did a calculation that said that for black holes that are a certain amount of mass, they should be able to steal like a certain limit of stuff. And therefore, that amount of matter that they steal correlates to how bright they get. So it says that the black holes should get to a certain brightness. But, all right, I'm going to put you back in your fridge, buddy. So sometimes black holes get way brighter than they're supposed to. And when they do that, we don't know how to explain what's going on. But we think that there's some kind of force that's pulling even more material and to make it even brighter and brighter than we would have thought. But even that's really not well understood. But the environments that happens in is also not well understood. So these really bright sources, so the brightness, they're limited to a certain brightness, and they get maybe 10 to 100 times brighter than that. And we don't know how to explain that, except that, so there's a few ideas, but somebody thought that if you increase the mass of the black hole, that would explain why it would get brighter. But it turns out that the black holes that are pulling this are actually lower mass. And that's pretty weird and mysterious. But yeah, if you have any other questions, you can feel free to ask them in the comments. Or, let's see, I can talk about... I can talk about globular clusters. Globular clusters are really cool. They are these big balls of stars, and it's like, imagine like 10,000 stars all clustered around together. And the stars are interacting with each other. So it's kind of, I think it would be a really interesting place to be in because you have like all these stars going around in circles with each other. And but one of the things that's funny is that they're older environments. So stars only live for a certain amount of time. If you're a more massive star, you burn through your fuel faster and you live shorter. So the stars that live the longest are going to be redder stars that are the smaller stars. And so the smaller stars actually wind up living longer. And then there's kind of stars like our sun are a little bit in between. Okay, Andrew and Louisa have a question. They want to know how many black holes have been identified. So it's really hard to identify black holes because we can't see them. So we have to measure them indirectly by looking at how they interact with other objects. And we've done that for the black hole at the center of our own galaxy. We've done that for more massive black holes at the center of other galaxies because we've kind of watched the motion of other stars that rotate around them. But probably less than 100 have even been measured, but there's also a lot of candidates. So a black hole candidate is when we think something's a black hole, but we don't know for sure, because we can't know for sure until we measure it. And so there are a lot more black hole candidates than there are confirmed black holes. So there's a few in X-ray binaries, like Cygnus X1 is one that's pretty cool. And that one they also had to measure, there's a technique called reverberation mapping. And what happens is when you have the black hole will accrete material onto a disk, and then it can give off optical and X-ray light. And so when we look at the two different lights that are created by the same source, we can see if there's a lag between them, and the mass of the black hole is related to that. But black holes are not always at the center of galaxies. Sometimes they're in globular clusters. So those are those big clusters of stars I was talking about. And that's kind of weird because it makes sense that you would have a black hole at the center of a galaxy because it's driving, like the motion of our solar system is driven by the black hole in the center of our galaxy, and like everything is revolving around that. But for globular clusters, it's kind of weird, and you wouldn't expect that because because the system is so many stars jumbling around each other that when they interact with each other, people expected the black holes to be just thrown out completely. But it seems like the black holes actually stay mixed in. And so somebody actually measured the first ever black hole in a globular cluster, which was exciting. So Vita has a question. So why are galaxies called a galaxy? And that's kind of a funny story. So galaxy comes from the word galactos, which is a Greek word. And this is purely historical, the naming. And there was a Greek word that was called galactos, and that's what the Greeks called the Milky Way. So galactos, if you recognize the word from it, lactose means milk. So the Greeks were the original people to call the galaxies the Milky Way, and the term galaxy stuck around. So when we say galaxy, we're kind of actually saying like milky objects, which is kind of funny. The other thing that is interesting, so when stars collapse, they form black holes, but sometimes they form neutron stars. So neutron stars are probably one of the densest forms of stars. It would be kind of if you imagine packing the whole Earth and squishing it down to the size of something like a teaspoon. So it's very, very dense, but it's not dense enough to be a black hole. But neutron stars are highly magnetized, which is cool. So just imagine like this little dense ball that has these big magnetic fields around it. And so they can use those magnetic fields to interact with other things and push them around. But they're cool. The other thing that we've seen that's kind of a new cool discovery a few years ago is we actually were able to observe a black hole and a black hole merging into each other. So what happens is you can have two black holes orbiting each other, but because they're both so massive, they'll put pressure on each other, and then they'll actually spiral into each other and collide and form another black hole. And this process is called gravitational wave emission. And so what's happening is the two objects are so heavy, they're actually rippling like the fabric of space-time. And those ripples come through to us, and we were able to use, there's this facility called LIGO, and they were actually able to measure the gravitational waves using lasers. So they have a bunch of lasers all over the world, and when the laser gets disrupted because of a very small change in space-time, they can measure that and then trace it back and find the two objects that merged with each other. Another cool black hole discovery that happened pretty recently was the black hole in M87. So they were actually able to take a picture of the black hole for the first time ever. So they didn't actually, remember you can't take a picture of the black hole because there's nothing to see there, but you can see how it interacts with other things. And so they were able to take a picture of the accretion disk around the black hole, and they did it using radio waves. So the radio, like when you're in the car and you listen to the radio, those kind of radio waves, they actually were able to use that to look at a black hole, which is pretty crazy. Yep, so if you have any other questions, feel free, but I'm probably going to take off soon. I gotta get back to work. But you should definitely feel free to post questions here, and I can follow up on them later. And if you're interested, I can put together some pictures of like the black hole that was observed and a little bit about the gravitational waves. So thanks for joining me, everybody.